Forgot to press record, so I'm just hitting record, and recording. The session is being recorded. Excellent. Okay, so just to get you up to speed, this is what the design of my Codename 1 library looked like on the Android side of things. And on the iOS side of things, it looks roughly the same. We're using, of course, the same public API because that's a cross-platform set of classes. Everything's centered around the central class, Moby Help, which follows very closely the Android API that FreshDesk provides. And there's a few POJO classes for passing data back and forth. There is a native interface for piping information from the public API to the native layer. Now, on Android, the native layer was written in Java, so it was very familiar probably to you Java developers. On iOS, it's written in Objective-C, so there's a little bit, it'll be a little bit more foreign if you're not familiar with Objective-C. There's also a layer that we have to call back into the public API in case the native layer needs to post an event, such as a callback for an asynchronous operation. Okay, so now into the iOS layer. So the first step in producing the iOS layer, we have to copy all the resources from the FreshDesk SDK into the native iOS directory. Now, the FreshDesk SDK they provide on their website, and we'll go to that website and take a look at some of their documentation in a moment. But the SDK is distributed in the form of a header file, some bundle files with resources like images that they need, and also a .a archive with the actual binaries. And you would just copy all of that into the iOS/native or native/iOS directory. Then when we generated the native interface stubs, you'll find that in that same directory there are two files created for the native interface. So here's a look at the native iOS directory after I've copied all of the FreshDesk SDK into it. I've got my two files here that were generated when we generated the native interfaces. We've got a header file that defines the essentially the native interface, and a .m file that is the implementation of that native interface. And we'll take a look at how that was implemented shortly. Then the rest of these files in the red box here are from the FreshDesk SDK. So all the API is contained in a single mobyhelp.h file. So in order to use their SDK, we need to include that in our .m and .h files. Will Codename, I'm just seeing a question here, will Codename 1 be able to support native APIs like auth, O, and aviary? I'm not familiar with those APIs, but the answer is generally yes. I mean, we're developing right on native code, so you should be able to do just about anything. Okay, so in this case with the FreshDesk, it's important, I'll take a look at those docs after the presentation, but I don't see any reason why any SDK shouldn't be able to be ported into Codename 1. Making sure we import the Moby Help SDK. Now, there's a couple things I want to talk about before we get into the specifics of the FreshDesk API, just to get you familiar with writing code inside the environment of the iOS Objective-C interface. So you have to know a few things about how the Java is compiled down to C code in case you need to interact with that C code. Now, you can always call Java methods, and static methods are the easiest thing. If you've defined static Java methods inside your application, you can call them straight from the Objective-C layer. So here's an example. You can see on the top there a Java function definition, which is in the Moby help native callback class, fire unread updates callback, and it has 3 int parameters. So that's just a very simple Java static method. Now the C definition equivalent, if you wanted to call it from your code in your native interface, replace the dots with underscores. So we got com underscore codename1 underscore. So the full package name and class name, just replace the dots with underscores. Then another underscore in the method name, followed by 2 underscores at the end of the method name, and then your parameter types. So in this case, it takes 3 ints. So we got int underscore int underscore int. Now this is the void version, and you'll see that I'm going to talk a bit about in a moment. It does take a first parameter of ThreadLocalData. That's something that we just pass through to keep track of the thread information, and it takes the same 3 parameters. Technically, actually, those int A, int B, int C are Java int A, Java int B, and Java int C. But for simplicity, I'm just showing this. And now for non-void return types, the function name that's generated in C will have the return type appended to it. So you'd have, at the very end of all of your parameter listings, you'd have underscore capital R underscore and then the return type to the end of the method. So as an example here for Java lang integer parse int, it's a familiar static function that returns an int and takes a string. So we've got Java underscore lang underscore integer underscore parse int. So that's the full package name and method name. A couple of underscores, then underscore Java underscore lang underscore string to represent that it takes a string as a parameter. And then because it returns an int, you give it an underscore capital R underscore int. And that will get you that's the definition of that method when you're calling from C. And of course it takes the thread state data also, and the string is passed, any object is passed as a Java underscore object. I'm not going to go into details about how to use that, but these are just the bare minimum. And looking at these definitions, one thing I said last time, which I still stick by, it's a lot easier to use your Java APIs if they only deal with primitive types. That way you don't have to worry about, well, how do you use this Java underscore object? How do you call methods on an object? If you just pass primitive types back and forth and do as much as possible on the Java side, you don't have to worry about any of that. You're just passing primitive types. So a little bit more on that ThreadLocalData first parameter whenever you're calling methods in Java. There's a few macros that just make this easy to get that thread data. If you want to get the current thread state, you can use the cn1 underscore thread underscore get state pass arg macro, and that'll get the correct state information that you can pass to any method. So, and there's no comma required actually with that one if you're passing it through. So here's an example here in yellow, calling my Moby help native callback fire unread updates callback, which is the static method that I created in the public API to be able to easily call back to notify that the asynchronous reading of the unread updates is done. So at the very beginning of the parameters, you see I'm using that cn1 thread get state pass arg. That's going to get the current thread state and just pass it through. So it's just a boilerplate thing you got to put at the beginning of a function call. Now, there's a different macro if there's no arguments, and that's just cn1 thread get state pass single arg. And the only difference between, if you actually look at the definition of those macros, is one automatically appends the commas, so you don't have to include it, and the other one does not. Another thing that you will probably need at some point if you're writing native APIs on the Objective-C is you'll need to know how to access the application's current view controller. Now, in the iOS world, every view will have a view controller. And so if you're using a library like FreshDesk that opens up some sort of new form, a new window, it often takes a reference to your current view controller so it knows how to get back to your application or to your previous view when it's done doing its thing. Now, Codename 1 uses a single universal view controller, so it simplifies everything. The whole app has a single view controller, and the Objective-C class name is Codename1_GLViewController. So if you need to access the view controller, and you'll see this in the API when we're going through it, I'll show you where it's asking for it. Make sure you import the header file for GLViewController, and then you can access the instance using this class method, Codename1GLViewController instance. And that gets you the instance, and you can pass that through when needed. One last thing I'd like to talk about before actually getting our hands dirty with some code is talk about threading. So in Codename 1, most things are running on the EDT, or the Event Dispatch thread. If you've been following forums or you've been using Codename 1 for any length of time, you're familiar with the EDT. All the application starts on this thread. All UI accesses have to occur on this thread, the Codename 1 Event Dispatch thread. Well, the native iOS code, in contrast, usually runs on the main thread, and anything that updates the native iOS user interface stuff has to run on the main thread. And this main thread is a different thread than the EDT. So if you're running code that has to access the native iOS UI in some way, UIKit, then you need to make sure that that code is running on the main thread. But if you're calling from a native interface, unless you're taking great care on the public API, probably that'll be coming from the EDT. So iOS and Codename 1 both offer ways to run a set of code on their main thread or EDT. So when you're calling in from your native interface on the EDT, and you've got some code that maybe opens up a new native form or something like that, you need to make sure that that's running on the main thread. So you wrap it in a call to dispatch_async. There's also a dispatch_sync, which is the synchronous version. Dispatch async is usually my go-to unless I need to wait for it to be done. And it takes a block of code and it sends it over to the main thread in the queue to be run on the main thread. Now you have the same opposite problem. If you've got a callback that a native library is making, oftentimes that's going to be happening on the main thread. So if you're using that callback to run code that's ultimately going to be handled in your public API, it's best practice to make sure that's going to run on the EDT. So you're going to wrap that in a display.callSerially method, which does the same thing. It takes a runnable and it'll run that runnable on the EDT. So this is just a consideration that you have to make if you're talking back and forth between Codename 1 and native. We had to do the same calculation in Android because it has its own event dispatch thread too, and we talked about that in the last presentation. So here's looking at the exact code for that, because we do have a method in the FreshDesk API for getting the unread count and passing it a callback that's going to be called back at some time in the future. So you can see in the first code example here, the get unread count async, the first thing I do, because I know it's going to be, it could be requiring the main thread, I'm going to call the dispatch async, the first parameter being dispatch get main queue, and that gets a reference to the main queue, so it'll run on the main thread. The second parameter, it's actually passing an Objective-C block, and this may be scary if you've never looked at Objective-C. Don't worry, All you got to do is look up Objective-C blocks, do some Google searches for dispatch async, and it's actually quite simple to get a hang of. But everything that's inside this block will be run on the main thread. So we've got Moby help, shared instance, unread count with completion, and that is going to pass another block as a parameter, and that block is meant to be called when the operation is done. So inside that, you can see inside my blue box I've got marked, that's where I'm actually calling back into Java. That's where this code is running when the operation is complete, and I'm sending the callback. Now this is probably going to be running on the main thread. So when we're calling back into Java, let's take a look down below at the second code snippet at that fire unread updates callback method. So you can see how I handle that situation on the Java side of things. So because I'm pretty sure this is going to be run off the EDT, I wrap the whole thing in a display, get instance, call serially, and I call a runnable so that the actual callback that I'm going to be sending back to the user of my public API is running on the EDT. These slides will be available for download. I'll send out the link after if you want to study these. It's really not that tricky, but it's a very important concept. If you start throwing event callbacks off the EDT, or you're not careful about making sure to run the native UI on their version of the EDT, which is the main thread, you'll start to run into just weird problems, and they can be very hard to debug. So just making sure the native is running on main and the Codename 1 is running on the EDT, you should be good to go. Of course, there's exceptions to that rule for certain types of things, maybe networking or long-running operations. You don't want to have blocking the EDT or the main thread, but for the most part, just simple callbacks, Codename 1, be on the EDT, native, be on the main thread. So I've talked a bit about, well, we implement our native interface. It's Objective-C though, and we import the SDK. And testing it out, what happens when there's a build error? Because what's happening is this code you're including in the native directory, it doesn't actually get compiled until the build server. So you don't know until you're sending in your app or your library to be built on the build server whether or not it's going to succeed. And that's where some of the debugging comes into play. So the strategy I generally use is check include sources on the properties for the application that you're sending, and that'll send you back an Xcode project. Unfortunately, in order to debug this Xcode project, you need Xcode, which means you need a Mac. So that's not ideal. But if you're going to be doing native integration, realistically, you want to be able to do that. But the good thing is, once this is all nailed down and the native portion works, you don't have to worry about that anymore. You put it away, and you've done everybody else in the Codename 1 world a favor, because everybody then can use your well-tested library, and they don't have to have a Mac, and they don't have to have Xcode installed. Okay, so I think in this slideshow, I've covered all the prerequisites we're going to need to understand. Okay. Okay, so sharing my screen, let's look at NetBeans now. So I've got my CN1 FreshDesk demo here, and let's take a look at the native directory just so you can see what I've got here. So I've talked about the native iOS. I've copied the bundles in. Just to take a look at where I got the bundles from, here's FreshDesk's SDK page. Now every SDK that you're going to try to integrate is probably going to have some sort of documentation. This is fairly typical. The last time we went through the Android documentation, here's the iOS documentation, and they've got an integration guide. And this is where I found the libraries that I needed to download. So it's got a few tips there. It tells you about some of the binaries, or some of the libraries that it relies on. That's another thing that is very important. I'm going to show you in a moment. Where is the actual? I guess that was just contained in the download. So here's their SDK. I'll start from square one. So I'm downloading their SDK. So I can take a look through it. It comes as this zip file. Okay, and so here's the full SDK. It's got this archive, libfd, mobi help SDK. That's all the binary code of their library. It's got a localization folder. It's got a couple bundles. It's got the header file, which includes their API, and it's got release notes. So let's look at the file here. So with only one exception, I basically just copied the whole thing into the native iOS directory. The exception being MH localizable strings. I ended up just, I had to pull that out of the substructure and just throw that at the root of the project. It's just to do with the way the build server actually generates things. It doesn't allow full nested structures. So I need anything that's important needs to be put up at the root in your iOS directory. .bundle, which are actually folders, seem to be an exception. The build server knows how to handle that and just keep them together. So let's take a look. Now that I've got these in here, here's the mobihelp.h file that they have. This is their public SDK. And it's got all the definitions of the functions that we're going to need, and some and the classes. And it's got some documentation here, and this is where I basically figured out most of the things, and I'll to get equivalents for the Android methods. The alternative is they've got some, if you're trying to figure out how to use it, is they've got some iOS API docs. We can look at the Mobi help, and it's got all of their methods here. You see that the names are a little bit different than the Android equivalent. Like here we've got present support on the Android API docs for the Mobi help class, which is the equivalent. It doesn't have a present support, it's got a show support method. So we named our methods after the Android idioms. So we just have to know when we're implementing on the iOS side the equivalencies. So let's take a look at the implementation. So actually first I'll take a look at the header file. So in my header file, most of this was just automatically generated by Codename 1 when I generated the native interfaces. I added this import mobihelp.h so that I'm importing the API that I need. All these methods are unchanged, and I've added a reference to the Mobi help config object because just the way I'm doing it, I provide a number of methods for updating the config that is ultimately used to initialize the API, and for that I'm just storing a persistent reference so that I'm using the same one every time and I don't need to pass it back and forth. So looking at the implementation, notice at the top here, most of this was, a lot of the stubs at least were generated automatically, but I am importing the view controller because for most of the methods where it's presenting a new form, it needs a reference to the view controller. I put this was not generated, I put just a helper method to access the current Mobi help config. And so these are generated. This is just setting the config parameters. It's piped straight through, generally as strings. So you notice that the API strings are passed directly as NS string objects, ints as ints. So these are all primitive types or strings, but they map to the native iOS equivalent. So some of the more interesting methods here. Here's an example, whereas the show support is the one we're going to focus on here. I'm using show support. That uses the method name for our public API and our native interface. We've got a dispatch async call, which is like I was talking about. We want to make sure if we're going to be using the native UI kit that it's running on the main thread. Moby help has this class method to get an instance of the Moby help, present support. There we go. And we're passing it a reference to our view controller. So it's a very, very thin wrapper. You'll notice there's no long methods here. They're just very thin wrappers around the native SDK. The thinner the better, because if we run into errors, it'll be harder to debug. And in fact, so I can actually build this now. I've got my CN1 FreshDesk demo. I've got everything there. And I can go codename 1, send iOS debug build, and that'll send it to the build server, and it'll compile it on the server. If there's an error, it's going to tell me there's an error, and I might end up having to either look at the error line on the error log, which is time consuming if you get too many of them, or I might end up commenting out the problem areas, then sending it through and using the show source method. And let's take a look. I'm just going to hook up my iPad here so you can see the FreshDesk API. Okay, let's. Hopefully you can all see my iPad here. I'll find out in a moment if you can't. But so here's I've got an iPad Air 2, and here's the CN1 FreshDesk demo. I just made a simple app that has the show support functionality that I showed you. So clicking on this show support button pops up. This is a native dialog that's part of the FreshDesk API, and it gives you sort of a built-in support option where people can write their help things, and it's connected to their whole system to feed you through with the proper support options. So I'm not going to do too much here, just to show you. Close it, and then we're back to my application. So it's integrated very smoothly. There's not a lot of rough edges or none. It's there's no leaving your application in order to do this. It's all happening inside your app. Okay, now before I go on, I'm just going to look at, okay, so everybody could see my iPad there. I didn't actually test to, I shared it with my screen. Can somebody just write in the chat and let me know that yes, you could see the iPad? It's not on there now, but okay, excellent, excellent. Okay, so this should give you enough to start actually implementing some native stuff on iOS. I will warn you, there may be, when you're going into some other APIs, a little bit of a different type of distribution than the FreshDesk that you might have to do some things to, but this is the general process, and it works. So the next, before I go on, because there's a couple other things I want to show you, but this is the end of what I wanted to show you with the FreshDesk API. Can you remind about the, I'm just reading a chat thing here. Steve, can you remind about the generate process? And we've got a question from Mickey. So I got two questions. Okay, I'll answer Asaf's first. Oh, the generate process. Okay, the generation. See, I had my native. Okay, so Moby Help native. So this was the native interface that I generated. It extends the Codename 1 native interface interface. And to generate the stubs, I just right-click on this method and say generate, on this file and say generate native access. And it'll generate it for all platforms. And that's where I got the stubs from, which is most of the work. And yeah, and Mickey, I'm using something called, I know Shai uses something called Reflector, I think. I'm using something called Air Server. It's a commercial thing, but you saw the little watermark. They gave me a 7-day free trial. Even though I bought it on my other computer, I could not figure out how to use my license. But it seems to work great. It hooks it up to AirPlay, and it just automatically pops up on my Mac. So it's yeah. So any more questions before I move on to the next portion? The next portion is more or less some show and tell and looking at some of the cool things. And I'm going to get Ram to talk a little bit about his development of Y homework. So any questions before we move on to that? Speak now or hold your questions for another few minutes. Okay. I'm going to pass it on to Ram in a moment, but first I'm going to remind you what Y homework is. Okay. Excuse me while I'm just going to open it on my iPad. Okay. So this is Y homework. I showed this a few back, and it just allows you to. It can work as a simple calculator. Oops, obviously I'm doing it wrong. Factorize. Well, that's even more interesting. 5 by 3, 15. It's got a neat little tutorial feature that actually shows you it in action. So here it's going to draw a graph. And they've done, I think they've done a really good job of, press draw, really good job of making a user interface that looks really friendly to use. And this works cross-platform. So that's Y homework. And now I'm going to pass you on to Ram. I just have to activate his mic. Okay. How do I bear with me here? There we go. Okay, so I've activated your microphone. You may have to additionally turn your mic on, but you should be able to address the crowd. Just give a moment here. Well, Ram, are you there? You can either just reply or say something in the chat. He may have stepped away for just a moment there. So while I'm waiting for Ram, I'll go on and just show another thing that I've been working on. Okay, so I've been working on just the last couple of days making some user interface examples for Codename 1. Oh, there's Ram.
Anyone hear me?
Yes, I can hear you, Ram. Can you hear me? Okay, I'm going to mute my mic.
All right. All right. So first of all, thank you very much for this opportunity to speak to you guys. It's really great to see how the community is growing. I'm the developer of Y homework, and I've been working with Codename 1 for what, about 3.5 years now. Starting off, it was basically just a couple of hackers working on this new framework, and I took a big chance on it and figured the cross-platform would really help me because I was sort of like starting in my way, didn't really know if I was going to focus on Android or if I was going to focus on iOS, and actually changed strategy in midstream 3 or 4 times. And the fact that I was able to develop a cross-platform tool really saved me from doing the entire work over and over. What can I say? I have now deployed Y Homework, which is installed in like almost 3 million devices by now, getting beautiful traction. You're more than welcome to install it and, of course, rate it highly and refer all your friends. Kidding. It's been able to give me pretty much every tool that I ever needed. I mean, I've challenged Chen and Shai and now I guess Steve with pretty much any wild idea that I had that I wanted to do and implement, and they've always come back with a solution. If it wasn't in the framework as it is, they were able to add it pretty quickly, really responsive to all of my questions and all of my my needs in that sense. Another thing is that, as you can see in this webinar, it's really extendable, so that when you get stuck, you can start writing native code if you ever need to. And this, while this is never your first choice, it's really a great fallback to have, so that you're certain that you're going to be able to do whatever you want, because if worst comes to worst, you can always start writing native code. And right now, in my experience, native code is much less than like 1% of your code. So really, for the other 99%, you're getting truly cross-platform, which is beautiful. As you can see, my app is full of animations, and it's really responsive. It's really working. It's really lived up to all of the promises. Other than that, what can I say? It's really great to see that the community is growing, because the more people that we have on this platform, the more the community grows, the more that we all benefit from it. I think that when I joined in, like in the early days, it was really just beginning, but by now it's really a mature and stable environment. You can develop many types of apps on it. It's not just limiting you to like a very specific use case, but it's really a very versatile and very it supports pretty much everything that you want to do. So if you're not creating a real-time game or anything like that that really requires the last bit of the abilities of the CPU, I recommend it highly. If you're new to this, give it a chance. I think you'll be very pleased, both with the performances and with the true ability to write once and run on all platforms. Many others have promised that, but I think this is the only one that actually delivers this. So give it a go. Back to you, Steve.
Okay, thanks, Ram. Oh, I'm just gonna.
My pleasure.
Okay, so we're almost out of time, but I wanted to show a little thing I've been working on the last couple days. And just a second here. Let me see if I want to see if I can get my iPhone hooked up. There we go. Okay, so this is now an iPhone 4S that you're watching here. So I don't know if you've seen, I received this little free UI mock-up set of Photoshop files in my Facebook feed. And so I decided, hey, why don't I download this and just try to follow up on the PSD tutorial that I did, just to try to give an example of some of the cool stuff you can do with Codename 1. So this, I just took a Photoshop file, and it's sort of a news type site. It's an inline video. Just to show some of the things that can be fairly easily done. I'll show you the actual PSD file because it's free to download. And now, kit. Okay, so they designed a few really nice screens, and so I'm working on just creating a demo news style app like this, and so far it's been really smooth to use. I'm using the CSS plugin that I showed a few weeks back to implement a lot of this stuff. One thing I wanted to talk about right now is I created a simple component for this. Okay, so this view right here, which is sort of a news article view, Arctic sea ice extent hits record low, and you can see it's got some inline images, it's got some quotes, it's got some paragraphs. Now, the built-in offerings for showing, this is kind of like showing a web page. For showing HTML, weren't satisfactory to me. Codename 1's built-in, the web viewer is fantastic, but it's a heavyweight. It's a native component. I want to use a lightweight Codename 1 component to show this type of article. The other option that Codename 1 has is the HTML component, which is a little bit slow and it's overkill. Most of the time on mobile, when you want to show sort of a web page like this, you've just got 4 different types of things. You got paragraphs, you've got maybe some inline images that take a full width, maybe you've got paragraphs with a special type of styling for the whole paragraph. Here's a bold, here's a little block quote, and sometimes you've got inline videos. So this is a very common use case that we might want to use, and so I whipped up what I call an XML view that I'm going to be releasing shortly that can handle a very simplified HTML or XML syntax to render very similar to this. So my version of that, I'll put this up again. Okay, just to look at it again here. So here's the sort of the news page, and you can see how it renders. I've got a built-in video component that was generated. I'll show you the XML that generated this in a moment, but it just takes a video tag. I can click on it, turns to a video, and then if I scroll it out of frame, I've still got a little rough edge there that I got to clean out. It changes back to the button, so it scrolls very smoothly. It allows you to style paragraphs using the regular Codename 1 mechanism, and this is very lightweight. It performs very well. It doesn't bog down either your performance or the app size, and it makes it very easy to have a portion of your app that shows kind of like articles, like this one here. So just to, I'm not sure if there's if you can see much from the code, but this is a package that I will be outsourcing, or not outsourcing, but open sourcing. So we've got an XML view class that is basically like a web view but it will consume an XML feed and be able to turn various tags into appropriate views. For instance, a video view, paragraph view, image view, carousel view. And to show, for that example, what the XML looks like, so it's pluggable, so you can create your own tags and have them transform into any component you like. But in this case, it's just making use of paragraphs, videos. You can see here I provided a UI ID for a paragraph, so that gives that orange block quote, and then an image tag. And it's very, very lightweight and very simple. The component itself just uses a box layout along the y-axis, and then it goes through and renders each tag as the appropriate component. And if you wanted to create your own tags, it's very easy to do. You just implement a one-method factory interface and pass it to the XML view, and your factory just has to convert an XML tag into a Codename 1 component, and then the view knows what to do with it. So this is a nice simple component that I've done to help with this type of app, and it'll be available very soon. How do you do the rounded text fields? Well, wouldn't you like to know? That's with CSS. The CSS component that the CSS module that I created for Codename 1, just it'll do gradients, it'll do rounded corners, it'll do all kinds of stuff like that to just automatically, and it generates them as multi-images and stores them in the resource files, so they perform very well. And they're very easy to do. To take a look at the CSS file for this UI kit, here's the kit CSS. Okay, yeah. So I've got my CSS directory, and I've got my now UI.css, so you can see with the CSS file. So I've made these CSS files so that it can completely replace a theme file, and it compiles to a theme file. You can specify what the resolutions you want to cover are using a special device ID, and you can specify all the constants of the theme using just the special constants. So an example of the rounded corners, border radius. So here's the text field CSS to get that. So I've got a background color of white with an opacity of 0.102, then a border radius of 20 points, and then it generates the image with 200 point and 40 point. Points are generated specially as opposed to using .px. Point works with the different scalings because it generates the resulting image in all the different resolutions that you're going to face, very high density, medium density, so that it'll work on all devices. Okay, let's see. Any more questions? Let's see. Program use. Oh, what was okay? That's that. I think it would be great to have a UI session in the near future. Agreed. Yeah, there's so many options that Codename 1 provides for producing UIs that are just as good as native, and are actually easier to generate than if you're doing a native app. That there's a lot of different sessions that we could put on that. When we use dimensions objects in CN1, is it px or millimeters? I think by default that's PT. So the dimension object in Codename 1 is going to be px usually. I mean, there might be cases where some other configuration says it's millimeters, but in every case I've run across, it's px. Always px. Shai just clarified, always px. So the trick I usually use if I want to be setting a dimension that's relative to things is I'll either work on the width. I'll get the width of the container, which returns px. I'll get the width of the device that returns px, and then I'll multiple that. Or a nice trick is to get the font height, which you can specify if you're using TrueType fonts to be in millimeters, and you can do some multiple of the font height if that's what you're looking for in code. Can it handle multiple styles like bold or underline with within the same text field? I haven't. The short answer, no. But there is some work built into Codename 1 to be able to possibly build a component like this. It gets a little bit trickier when you're talking about like when you're doing the actual editing, because then we have to depend on what the native text fields are capable of too. So short answer, no. But depending on what you need, there might be something that you can do to get around it. Can it handle multiple? Okay. Any other questions that? Okay, we got a couple guys typing. Nikki and Asaf. Can it handle multiple styles like within the same? Oh, with UI questions, we can go all night long. Can we? I mean, I'm finished the presentation, and I will stick around to answer questions. So if you do have UI questions, you know, throw them at me. We've also got Hen and Shai here right now, and we've got a few guys here that are quite experienced with Codename 1. So that's one of the benefits of these meetings. If you got things that you're wondering about, ask away and get the hive mind working on it. Okay, so if there's no other questions, I'm going to declare this presentation complete, and I'm going to hang around in the chat room for a little while if anybody wants to chat or ask questions. Thank you, everybody, for coming, and I will be posting the slides soon, and also posting the video soon if you want to review this.